Hello everyone, it's August 18th. Alright, let's do this. Find critical something something. Find critical and pseudo-critical edges in mining minimum spanning tree. I forgot, what's the minimum spanning tree? Is the minimal. Given a weighted, undirected, connected, weighted, undirected, connected graph with n vertices, number from 0 n minus 1 and array edges, okay, and we have a, b, and weights. Represents a bidirectional and weighted edges between a and b. A minimum spanning tree is a subset of the graph's edges that connects all vertices without cycles and with the minimum possible total edge weights. Find all the critical and pseudo-critical edges in a given graph's minimum spanning tree. An MST edge whose deletion from the graph will cause the MST weight to increase is called a critical edge. On the other hand, a pseudo-critical edge is that which can appear in some MSTs, but not all. And then you can return the indices of the edges in any order. Huh? Okay, so that's the figure above. It describes the graph. The following figure shows all the possible MSTs. Now, what's MST again? A minimum spanning tree is a subset of the graph's edges that connects all vertices without cycles and with the minimum possible total edge weights. Total edge weights. What are the weights? I weights. Oh, these are okay. So are these two the same? 1, 2, 4, 7. 1, 2, 4, 7. 1, 2, 4, 7. 1, 2, 4, 7. Yeah, they're all the same. And the critical edges. So the first is the critical edges, right? The first is critical edge. Second is pseudo-critical edge. What's a critical edge? A critical edge. Given gross minimum, this. Cause its weight to increase is called a critical edge. Like if you delete that, it will cause it to go up. And pseudo-critical edges. So I think the critical edges are the one that's shared by everybody. Not necessarily. No, it is. Critical edge is the one that's shared by everybody. Yeah, it makes sense, right? So which means if you remove this edge, then it will cause MST weight to increase. Yes, that means that's the edge that's shared by everybody. And the pseudo-critical edge are the ones that which can appear in some but not all. So everybody else. So the ones shared is 0 and 1. Everybody else is 2, 5, 3, 4. 2, 5, 3, 4. Holy crap. How am I supposed to do this? I mean, finding the edge might not be that hard because at the end of the day, if I can find MST, right, then I'll record what edges are in there. Then you basically go through all the edges. The edges are not that much, right? You go through all the edges, and you go through all of them. You know what? No, you just do if you put them all as set, you just do a set. Set intersection, right? And you find the edges that occurs in all the MSTs, and those are the critical ones, and the remainings are the pseudo-critical. So that's easy. So the difficult part is to find all the MSTs. All the MSTs. How do I even find all the MSTs? I have no clue. But we can try. I mean, it has to be the minimum. So maybe what we can do, and that's all has to be connected. What you, are you trying to just traverse everything? I mean, it's 100 with that many edges. So if you want, you can basically just DFS the whole thing. DFS the whole thing. Huh. Yeah, DFS the whole thing. Find the number of weights. You know what? Yeah, maybe that is the way to go. You DFS the whole thing, right? And you find out what is the overall weight, and you record the edges, and you can just record the indices, right? And at the end, you have the weights. You record the weights, right? You record the weights, and then you find the weight with the smallest weight, and that will be, so for each weight, it's like a hash map. For each weight, you want to append an array, right? And the array records the edges in it. Huh. I mean, depends on, I mean, it's only 100, so I don't know. With minimum 200 edges, so if you want to visit all of them, I mean, what's the time complexity to get through them all? Well, for each, you have to go through everything, and then you have to go through everything, you have to go through everything. Maybe we can also do a little bit, you know, memorization, right? So basically, like, if we go from 0, right? I say we go from 0. And then if you go from 0, I want to know, yeah, because it's connected. You go from 0, what are all the, yeah, because if you go from 0, you can find this, you cannot find these, you can find this, you can find this, right? You can find this, this. So what should I do? You go from 0. Okay, think about this. It has to be connected, right? So if you go from any nodes, you go from this node, I don't know, like what you're trying to say. You go to, has to be minimum overall. Yeah, that'll take a long time to find all of them. How do you find MST? Did I know how to do this? Maybe it seems like something familiar I've done before. Right? It seems like something I've done before. No idea. Hints. How to find the Crucial. I might have heard of this. Crucial. Minimum spanning tree algorithm. Crucial. I think this one sounds familiar. Crucial. Okay, we sort all the edges of the given graph in increasing order, then it keeps on adding new edges and nodes in MST if the newly added edge does not form a cycle. It picks the minimum weighted edges at first and the maximum weighted edges at last. Thus we can say that it makes a locally optimal choice in each step in order to find the optimal solution. It is a greedy algorithm. Okay, we sort, pick the smallest edges, check if it forms a cycle with a spanning tree formed so far. If it's not formed, include, else discard it. Repeat 2 until there are v-1 edges in the spanning tree. I was going to say, how do we decide? We can use a union find. Because if it's a cycle, that means the 2 edges are already in it. Yes, union find. Oh, I think I'm gonna chicken out. I don't want to use Java to write union find. Man, the amount of effort to put into it is gonna be ridiculous. Okay, so we just, you know what? Now that I think about it, this algorithm does make sense, right? You put the smallest, and then put a second smallest, and you keep putting the smallest, but that only finds 1, right? Yeah, that's minimum spanning tree. Okay, so Kruskal can find 1, but you want to find all. So if we use Kruskal, we're gonna get this, because that's the smallest. What's the next? Oh, I think I see the point. Well, the next is this. And then you have 2 and 2. Ah. No kidding. All right, then we do 2. Let's say we do this one first. And then we try to do this one. No, can't do, because it will cause a cycle, right? So I cannot do this. Next is going to be 3. So we can do 3, 4, or we can do 0, 4. Right? We have 2 possibilities, which is this or this. And we can say, we can say instead of do 2, 3, I do 0, 3. Right? Under 0, 3, I cannot do 2, 3, so I can do this, or I can do this, which is the So basically all the edges that appears once is going to be critical. Actually no. That's not necessarily true, because like 3, 4 might appear once when you get 3, right? Not really, but I think that reasoning is not solid. Okay. Kruskal. I gotta remember this. Minimum spanning tree, Kruskal. Okay, so we sort the edge. Ugh. And we even sort it with this. Yes, we can sort it with this. Right, we sort the edge. Yeah, I think I'm going to do it in a. Oh my god, I'm gonna do it in Java. Anyway, we're gonna sort this, and we're gonna start putting it in. Ooh, can we how do we handle branching out? Right, so we have the smallest. For each one. So we need a backtracking, right? We need a backtracking mechanism in the union find. How do I backtrack a union find? Well, when you want to add an edge, basically you put those into the same union, right? You put those in the same union. And if you want to remove them from the union, you can do that. You can do that. You reset those. You reset their rank to 0, and you reset their parents to themselves, and then boom, you're done. You have removed them. All right then. That is going to take a while, but I'm up for the challenge. I think it's going to be fun. I want to try it. Think it's going to be a lot of fun. Can't wait. All right, class DSU. What do you need? We need a int parent int rank dsu will pass a n, right? This dot par equal to new int n. We need to initialize it, but we'll initialize it later. This dot par, not rank, equal to new int. This is fine, everything is 0. Then for int I equal to 0, I smaller than n, I plus plus. We're gonna do this dot par I equal to I. Okay, that's initialization. Now we're gonna say int public int find. We find the parent of x. If parent x is not equal to x, parent x shall equal to find parent x. Then return parent x. Okay. Public boolean union int x int y. Int parent x equal to find x. Int p parent y equal to find y. I wonder, wait, is it, or should we? What does this mean? Y should probably not be passed as parameter x. I don't understand. Should I use this? No, I think it's defined. It's fine, right? Now we say if px is equal to py. Yeah, I don't know what this means. Does not match the value assigned to report assignments and function call in which the name of the target variable or the function parameter does not match the name of the value assigned to it. Int y equal to x. That's fine. If there's syntax, we return false, right? Already union. Otherwise, we say if rank px is larger than rank py, then parent py shall equal to px. Okay, else if rank px smaller than rank py, then parent px shall equal to py. Else you can say rank px plus equal 1, then parent py shall equal to px, and this will return true. Okay, so that's DSU. Now what we need to do is we need to define a function. It's gonna get a recursive function. And at the end, we want to, what do we want? What do we want? We want, oof. You got this, you got this. We want a hash map, right? So we want a hash map integer and int of this. Oh, hold on. Well, it's gonna always be minimum. So actually that's not true. That's not what we want. What we want is going to be all the edges for the MST. Right? So MSTs, lots of MSTs, and they are going to be set. Yeah, they're gonna be set, right? They're gonna be a set. Okay, they can be a set. So an array of sets. An array of sets will do. So we can say array list of set of integer. Okay, MSTs. That's fine. Okay. Then what? Then we need a function, which is private void find MST. Okay. What does this find MST needs? We need a edges index. Okay. Hold on, let me think. Yeah, I think it'll be better to hold a second. We need to find the minimum edges, right? So we need to turn edges into a, now we do need a hash map integer, and then this edges, we don't call it edges, we call it weight edge map, right? Weight edge map. Okay. Weight edge map. What else do we need? We also need sorted. So int sorted weights. Right? We don't know what it is. Sort weights. Okay, so now this one I just need index. I need DSU. DSU. We need a union find. And we also need, because it's gonna be a set, right? So we need a set of integer edges, current edges, right? Current edges. Okay. What else? Oh, we need index is going to be edges. So I know how many edges I have to be. Minimum spanning tree is n-1 edges. So int n. Right? Okay, so with all that, then I can start. Right? I can start. Find MST. I have so if index, is that index? Is that index? That's not index. It should be count, right? It should be count. So if current edges dot size, right? If current edges dot size is equal to n minus 1, right? So this we have found all the edges to form an MST. Okay, so now what we do is we do msts.add current edges. I have a copy. Oh, how do I create a copy? Create. I mean, if you think about it, you can just do it right here, right? Yeah, I don't need to do all this. What I need to do is at the end, we have whatever set we have, and we intersect with the overall, right? We just need to intersect overall. So what I need to do is a set integers all MST edges, right? I think that should do. It's going to be a hash set. New hash set, right? All I need to do is all the edges and set so this is all, and then you do the next one, you get some out, right? Because this has to be the one that everybody has. And then you will do intersect, and then you intersect with all the edges to get the similar out, right? And then the similar out intersect with the already similar out. Yeah, it's like 2 rounds of intersection. So your current edges intersect with all edges, right? With all edges to find which one occurs. No. You intersect, and then you intersect. Okay, yeah. This is better. So integers. So this is all edges and then critical edges. Right. So now once we have found all the edges, what we're gonna do is all MST edges dot add all current edges. I'm guessing add all means to add all the elements in the specified collection to this set if they're not already present. Yes. And how about critical edges dot contain remove to array iterator. Do you have intersect? How do I do intersection? Set intersection. Retain all. S1 now contains only elements in both sets. Copy constructor. Oh my god, I remember copy constructor. Retains only the elements in this set that are contained in the specified collection. Removes from this set all the elements that are not contained. If the special collection is also a set, this operation effectively modifies the set so that its value is the intersection of the two sets. So dot retain all current edges. All right, so that's that, right? And we're done. Else So else is we haven't reached the end, right? We haven't found all the edges. So now I'm at my index, right? I'm at my index. So what I need to do is to check this index what. So this index is relative to the works for sorted weights, okay? Index works for sorted weights. Okay, index corresponds to sorted weights. All right, so now I just need to go through all this, right? We just say for edges, right? For index, for int edge ei of weight edge map dot get sorted weights index. Okay, so this is the edge index. So I need to have int edges, right? And it is edges as well. So now I know whatever edge, right? I know the current edge, and we know int a equal to edges ei, right? Edges ei 0 because it's ab in value. Int b equal to edges ei 1. I actually don't even need the third one. It doesn't really matter. Okay, it doesn't really matter. So we get these two, then we need to say if I union them, right? If they're already in it, then we say, oh, if dsu dot union ab, if it's true, right? So ab including edge a b does not create a cycle. That means it's good, right? We include it, and then we can say find mst index plus 1 dsu, and we can say current edges dot add ei, right? We add this, then we do current edges, then boom, done. When we finish backtracking, current edges dot remove ei, and dsu dot remove. I should add a new function, public void remove something from this int x. Okay, then there will be parent x will equal to x and rank x equal to 0, right? This is equivalent to remove this value from the union find, right? Or from it. So we're just gonna say ds dot remove a, dsu dot remove b. We remove both. That's if they are not in it, right? This one turn true, which means they do not belong in it. Else ab edge ab, adding edge ab, right? including edge AB creates a cycle, so we cannot add it. We just skip, right? Otherwise we just skip. With the next one, blah 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 blah, and then we do this. So this one doesn't return anything. So once it's done, we will have created all of them. Okay, that's that. Now we have to create these things. First of all, this dot edges equal to edges. This dot n equal to n. Next, we need to create sorted weights. No, weight edge map first. Okay. Then we say for int EW of edges. Okay. What do we do? Oh no, that's not right. I need indices. Int I equal to 0, I smaller than edges dot length I plus plus. All I need is the weight, right? Then we can say weight edge map dot compute. Oh shoot, yeah, this one should be integer. It should be integer. Then we say compute if absent weights edges I 0 1 2 is going to be the weights, new integer this. Okay, compute if absent dot add I. Oh, that's not true. Array list. It has to be a list. Array list integer. My bad. It's an array list integer. Here is going to be an array list integer. New array list integer. It's not right. Huh. Nope, that's not what I want. It's gonna be hash map, right? It's compute if absent. I put the key, and if absent, I do an array list. How is this not right? Huh? No instance of type E exists so that I don't understand. What is the problem? compute if absent array list. Oh, shoot, I forgot the syntax. Ah, gotcha. It has to pass a function. Ugh. It's all right. Okay, so now I pass a function, now I compute if absent, blah, 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 we add it. Now we need to sort of weights, right? This dot sort of weights equal to new int the size is gonna be weight this dot size. Okay, then we're gonna go through. So for int w of, I'm guessing, dot key set sorted weights. Huh. Yeah, it's not the best. Okay, I'm gonna do array list. Okay, we do array list. And this is not necessary. Then I can just dot add w. Oh, I can collection at all. Ah, nice. Nice, at all. Great. Dot get index. Yeah, unfortunately, it's changed. Okay, so sorted weights dot add all, and then we can say arrays. No, I think this one dot sort. Comparator. I have to pass a comparator? How about arrays dot sort? No. No way. I have to comparator dot comparing int. No. What else? Natural order? Wait, hold a second. Sort array list. Collection dot sort. Or natural order. Okay, I think natural order shall be fine. Right, we add everything and we sort it. Now after we sort, then it's good. Now we can call find this. We start with 0. All right, DSU, we can say new DSU. What's the size of the DSU? DSU should be nodes, so should have n nodes, right? And the last is going to be a new hash set. Yeah, index 0. So when we're done, we're gonna return a list and a list of integers. So we're gonna return a new list integers. No. Oh, how do we create a list and list of integers? Okay, answer. Hold on. Answer shall result shall equal to new list new array list. Okay. Then rest.add. First array list is going to be critical edges. So critical edges dot to array. No. It has to be a list. Okay, how do I turn set to list? I have to do this. Can I say, doing it dirty, new array list, okay, dot add all critical edges. Oh, it's not right. Oh, it's gonna be a boolean value. Ugh. List integer critical crit edge critical edges list shall equal to new array list, and then critical dot add all critical edges. Does it make sense? Parameterized. How? Oh, you can do it directly. No way. Oh, you can use it directly. Oh my god. Then I don't need this, right? I don't need it. I just need oh, then can I just say as list? Right? Array as list this and this. All edges. Oh, hold on, this is actually not right. It should be all edges minus set minus another set. Find a difference. Gotta be a remove all. Oh, retain all and then remove all. Ooh. Removes from this set. Alright, so remove all. I think it's in place. Modify the set, yeah. Let me say all this dot remove all critical edges. And then we do this. And then oh shoot, what did I do? Then we can return. Okay. Madre mía. Generate pseudo critical edges. All right, how's this one go? Ugh. Index out of bound. Oh, you forgot to check that, huh? Did you? Yep, forgot to check. So L if index is smaller than sorted weights dot size. Yeah. Okay, pretty bad. That was pretty bad. That's okay. I mean, we'll figure it out. What goes wrong? What do you think went wrong? I mean, it gotta be this. I mean, all MST. Oh, the second one is. Oh Lord, the second one is even worse. What? Dear me. Okay, we gotta debug this. It's all right. It's all right. We debug. It's okay. That's okay. I'll figure out why it goes wrong. So 0, 1, 1. Yeah, we can actually put this one away in. Just need to change. Okay. Then we'll change all this. Right. Change it all into this. And change all of this into this. Add one more here. Add one more here. All right, edges, solution, and yeah, it doesn't really matter. It should be find MST N and edges. Private access to solution. Oh, find MST is. Sorry, got the wrong function call. Okay, so we can call this. It gives this, which is wrong, right? Okay, time to debug this. How are we going to debug? We are going to debug by putting it here. So now we call it debugger. All right, let's see. Sorted weights. Sorted weights. We have 1, 2, 3, and 6. That is correct. All right, 1, 2, 3, 6. Critical edges. These are 0 edges. Is going to be this. That's good. And what else do we need? We don't have DSU yet. What about weight edge map? Where's weight edge map? Wait, where's weight edge map? Oh, here. Damn. Critical edges, all edges. Critical edges, all edges. Weight edge map. Watch. Okay, so 1 value is 0, 1. 0, 1, yeah. 2 value shall be key value should be 2, 3. 0, 1, 2, 3. And then 4. No, 3 shall be 1. 3 shall be 2 as well. 3 size is 2. 4, 5, and then 6 is by itself. Yeah, okay. So this one's correct. sorted weights is correct. Let's see, sorted weights. I sorted weights. Okay. All right. So now we're gonna go in. Step into. Choose a method to step into with arrow keys. To exit, we step into this. Okay, so current size. Current edge is 0. I think F8, let's keep going. And equal to 5. 5 minus 1 is 4. Right, so 1, 2, 3, 4. 4 edges. So we don't have anything, so we do this. 0. Sorted weights, size is 4. So it's true. So we check sorted weights dot get index dot get what's this EI? I mean, we start from 1, right? 0 and sorted weights 0 is 1. So weighted edge map dot get 1. So give me 0, 1. Right? So give me 0 and 1. If it give me 0 and 1, so I can get 0 or I can get 1. So I say, okay, I get 0 first. So EI is 0. The issue the union 0, 1. We can edges added, current edges added, find MST. So we find it again. Oh shoot. I shouldn't go index plus 1. Oh. I see the problem. You get the first edge and then you immediately go to the second value, but you should actually know. So you should do the first one, you do the second one, right? And the third one, and if the next one is overlapping, then you skip. But I think it's on each one, on each weight, you should exhaust it first. Okay, so what I'm saying is on the weight as 1, you just go add the first, add the second, add third, right? You can add third, but if you cannot, how am I gonna do this? I know why this is wrong, because at each index you have to add all the edges. You have to add all the edges at the current index. So you add this, and then you add this. You add this, okay, and now you can add this. And you try add the other ones, you can't. How am I going to do that? How am I going to do that? Yeah, and at the same weight, right? You have multiple edges at the same weight, and you want to add them one by one. And as you add the first one, okay, add a second one and you fail, then you skip it. Then you add the third one and you fail, and then whatever this is. Now the next round, so you record who gets added. So the next round, the ones gets added before you skip those. Oh my god, that doesn't seem and seem right, huh? Yeah, how do I find all the MSTs? Let me think. Yep, this is gonna take a while. How do I find all of them? All right, so I say weight is 1, I have 0, 1. Weight is 2, I have 2, 3. Weight is 3, I have 4, 5. Weight is 6, I have the last one. 1, 2, 3, 4, 5, 6. Right? So first I shall add weight as 1. So I add 0, I add 1, all good. Because 0, 1, all good. Next I shall check 2. So on 2, I shall add both 2 and 3. So I add 2, okay? Then I add 3, can't do it. So in that case, I shall do one situation, just add 2 and don't add 3. And the other case shall be add 3 and try to add 2. But how am I supposed to, handle all this? Maybe what I can do is, you have a bunch of edges, right? All of these edges have the same weight. So you start from here. You add this, you try add this, cannot, and you add this, you add whatever. And then you go another round, then you start adding this, right? Basically you skip this, right? You skip this. But that still doesn't work because you can add this. What if you have another one that's kind of, yeah, you cannot add this, and you add this. You add this. Yeah, how am I supposed to do this? Seriously, how am I supposed to do this? We have a bunch of them, and we need to find all possible. Can we even find all possible, all of them? We can add the first one, right? And then we try the second one, and we cannot. Then the next round. Oh man, how am I supposed to deal with this? I mean, every time you have to add the smallest, right? Every time you have to add the smallest. But what if you add the smallest, it doesn't work, then you skip it, right? You skip it. It's greedy. So every time you add the smallest, and if the smallest doesn't work, like the smallest gives you a cycle, then you skip it, then you add the next one, right? But every time you skip, there is a possibility. Oh, this is actually harder than I thought. There's a possibility that if you, because Crucial only give you one MST, didn't guarantee all MSTs, and what you want to find is all MSTs. Right? You want to find all of them. And yeah, the original one is not right. Oh. Okay. Hint number 2. I know that. To find if one edge is critical, delete that edge and rerun the MST and see if the weight of the new MST increases. Oh, that's a very different way compared to what I thought. Yeah, I know this. To find if one edge is critical, delete that edge and rerun the MST and see if the weight. Oh, that was a different way of thinking. I was trying to find all the MSTs and it fails miserably. So what this says is you run MST, okay, on the entire edge. And then you know the minimum weights. Then you delete one and you run it. If the weight increases, that one is critical. And then you delete the second one, increase as critical, and then delete. And if you delete it and it does not increase, but it has to be part of it, right? And how do you make sure it's part of it? I mean, if you delete this edge, it will not increase, right? Yeah, okay, so I understand about the critical edges. And how about the pseudo-critical edges? Which can appear in some but not all. Okay, I can delete. No, you cannot delete. Interesting. That's very interesting. I mean, I know the critical ones, right? So maybe I can add all the critical ones. Huh? How do you find a pseudo? All right, I have to read all the hints. The last one. Non-critical. Include that edge to the accepted edge list and then continue to see if the resulting has the same weight. What do you mean? What does it mean? So by hint number 3, we will get the critical edges. Okay, fine, cool. Then we will add those in. Okay, then I'll pick one of the remaining. I pick it, and then I keep running the result, the remaining, to see if it works. If it works, that means that one is good. If it doesn't work, that means that one is bad. Okay, I think I got it. Oh, now I will not be able to get it because my way of thinking is completely wrong. Okay, that's fine. Let's just change. Union fine, we don't have to change. This, yeah, this we have to change. So these things doesn't have to be on the outside. This we don't need. This we don't need. My. We don't need any of those. Let's stop debugging. Find MST. I just need the edges sorted. Okay, I just need the sorted edges. So this one must be sorted based on edge weights. Then we do find MST, right? Find MST, and all I want is to return an integer, which is find mst weight. Okay. We don't need any of this, right? We don't need any of this. I just keep adding. Well, I need the already part of the edges, right? I need the already start weight. So int initial weight, init weight. I have an initial weight, and the edges to exclude, right? So that's gonna be a set. Edges to exclude. Excluded edge. Now just say current edges. That's fine. Current edges. Then we just go through this. This is sorted, so go from front to end. If it's in this, we don't do, right? If it's not in it, we'll add to the weights. Okay. So what do we do? For no. I need the index as well. Oh my god. My god. We have to add another one, because we have to sort this. My god. Sorted edge, right? And element will be this. A, B, weight, index. Okay, so for int element of sorted edges, oh no, my bad, sorry, int this, right? Int A equal to 0, int B equal to 1, int W equal to 2, int index equal to 3. Okay, then what? Then we say if index, if current initial edges, not don't call it current edges, initial edges. So if initial edges dot contains index, or more specifically, if they do not contain, that means that one we can add, right? That one we can add. But we also have to keep track of the total number of edges. Okay, total number of edges. So number of edges, num edges equal to initial edges dot size. So here we're gonna do, if it's not included, then we say wait. That's fine. We can just say initial edges. Let's redefine it. Weights, total weights, right? Total weights equal to initial weight. Okay. Then total weights plus equal to W. And hey, hold on. If this, right, and oh gosh, we need a DSU. Ugh. Oh my god. That's right. We need a DSU. DSU. What's that? DSU new DSU and for int A of initial edges, DSU dot union. You gotta be kidding me. I can't union this. Oh my god. Int I equal to 0. I smaller than Oh my, I smaller than initial edges dot size -1 I plus plus. So DSU dot union, you can't even do it. You can't even do it because that is not a, it can't even get everything out of this. Man, this is driving me crazy. This is driving me crazy. I have to turn this into an array. Oh. Okay. Yeah, I just have to turn this into an array, right? Int. Since I can do this, right? Init edges array. Init edges dot to array. Is that not right? Object integer. Huh? Required type, provided type. Wait, hold on. How do you use to array? How do you do to array? Set to array. Set to array in Java. What the hell is this? My bad. So it has to be to this new array. Zero. Okay. Then we call this. This has to be length. And union init this one I. And init edges array I plus 1. Right? So now we union this. Now we got all the union. Then we can start the sorted edges. And we say if initial edges not contain and DSU dot union union what A and B, it has to be true, which means they do not have it before. If it's false, then we don't use it. Then this one, this, and I already union it. What's the next thing we need to do? Num edges plus equal 1, right? Num edges plus equal 1. Shouldn't you check it before? Right? You should check it before. You should check it before. So if num edges equal to n minus 1, right? Then we break. Kind of want me to do it differently. Right? If I do a 4, then I can put this one. Yeah, that's what I think. You know what? If I have this, then I don't need this. Come on. I have this, I don't need this. Yeah, int I equals 0. I smaller than sorted edges dot length and init. We can just say edges array. Nice. Initial edges, yes. It's gonna be edges array. This is gonna be edges array. And then edges array dot length is smaller than n minus 1, right? If it's equal to n minus 1, that's it. Then I plus plus. Then we don't need to do this. Okay, this is gonna be a little bit more involved because all of this has to be changed to sorted edges, but it's okay. Ugh. That's so ugly. Okay, that's fine. Right, we get all these, and then we can do this total weights. And this doesn't exist. We just call edges array dot add. I cannot add. Oh, you gotta be kidding me. You cannot add. Oh, I'm going to strangle. Oh, I am strangling. This has to be array list. Man, this is killing me. This is killing me. This is killing me, man. New array list, but I learned I can just do this. This is absolutely killing me. Size. Oh, that's okay. That's okay. That's okay. Hold on. Hold on. We know. That's all right. It's all right. That's all right. We get this. We got this. I just need to have a little bit of patience. I'll get I plus 1. Okay. So, all right. So that makes sense. Yeah, it cannot be an array. Has to be a list. I think I need to rename it to list because it's a list. It's not an array. This is edges list. Okay. This is a fine. Now we can add. Oh, add what? Index. Right? Okay, so we'll go through. Oh my god. All right, we union blah 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 blah. Go through everything. Once we done, and then get out. Right? Once we get out, what are we getting when we get out? Well, when we get out, we will get the minimum. Then we just need to return the total weights. All right. So this we don't need. We need to say this dot sorted edges shall equal to new int that is before, right? What's this? Edges dot length. Okay. Then we do this. We say sorted edges I shall equal to new int edges 0, edges 1, edges, my bad, edges I0, edges I1, edges I2 plus your index. Okay. Once we're done, we say arrays.sort sorted edges comparator comparing int and a tuple. We need to go which one? 0, 1, 2. That's the edge weight. Okay. Now we're ready, right? We're ready. I'm gonna say int mean weight is going to be find this initial weight is 0. How do I do empty set? Collections dot empty set. Right? I do the initial weight. Why is this? Actual value will always be 0. I'll pass something else. Don't worry about it. So I'll do this. Okay. So blah 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 blah. We will get the total weight. So that's initial weight. Then we need to remove an edge. Remove an edge. What is remove an edge? The edge that does not include. So initial edge set integer removed edges. All right. So if does not contain and removed edges dot contains index. So it's not in the ones already in. It's not in the one. I mean, honestly, initial edge, I don't think I need to check this though, because I think the union find will check it for me, but it's fine. Let's just do this, right? So the initial edges cannot include. The removed edges cannot include. But this one, I don't have anything. I don't have anything. Now we need to remove each edge, right? Remove each edge and see if the mean weight increases, right? If it doesn't, if it does, the removed edge is critical. Makes sense. So we can have our first, what can I say, list integer criticals equal to new array list. Okay. Then for I just want edges, but it doesn't matter. So int element of sorted edges, doesn't matter. We just go through all of them, and we can go through edges or go through sorted edges. Doesn't matter. We have to go through them all anyway. So now we're gonna go. All we need is the index, right? So int index equal to element 3, 0, 1, 2, 3. That's the index. So what we do, we remove it, right? Then we say if find this initial weight is 0, initial edges is still empty set, but this is not empty set. New set. Ugh, not new set. New hash set. How do I initialize a hash set? Initialize hash set. Arrays.asList. Okay, so arrays.asList index. So if this is larger than what? Then mean weight. Okay, I have a problem. What's this problem? With only one argument. So, what do you suggest me do? List off. Huh? What's the difference between the two? What's the difference between array as list versus list off? Exactly. Immutable and hence thread safe is mutable and not thread safe. Oh, this is immutable. Yeah, we need to be immutable because this one is immutable. Okay, so if this, which means we will remove this and it's larger than the mean weight, so this one is critical, then we say criticals.add index. If not, we don't do so, blah, 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 blah. We have the critical ones. Now we have to add each edge, right? Add each edge to the potential MST and check if the actual MST has the same weight. as min weight, right? If it does, then the added edge is a pseudo critical edge. Okay, first of all, list integer pseudo critical is new array list. That's fine. Now we're gonna go through every single thing again. So let me just copy and paste this. Okay, so do this, do this. Now I have initial weight. What is your initial weight? Int initial init weight shall equal to 0, and for int index, right? Index of what? Criticals. Init weight plus equal to edges index 0, 1, 2. Right? So we have the initial weight. Now every time for each, oh, I need to make sure it's not in the pseudo critical. Oh, I need to create a set for pseudo critical? Oh, please do not do that. Please do not do that. Now I have to create a set for critical because I need to check if it's. Oh. There gotta be a way to do it. You know what? You know what? You know what? Maybe I can do something there. I don't know. Maybe there's something I can do. Like, let me think. Maybe I can change the sorted edges. I change something so that we can skip. Like I set the weight to maximum value to indicate that this one is not available. So if we do that, then we don't have to pass these two things. We don't have to pass these sets, right? But I still need. No, you don't need. I mean, you don't need these edges. I do need the edges. Because I need these edges to. Okay. That's fine then. That's fine. I just need a set of criticals. Right? I need a set of criticals. You know what? Let's make this into a set. Screw you. Hash set. It's the same, right? This can be a list. This I don't really care. But this one is a hash set. So if this is a hash set, I guess I can do this one as well. Yes, that's fine. So I can get initial weight. And every time I can just add it to it. Right? So it's going to be if index is not in criticals dot contains index. Right? If it's not in it, then we do something about it. Right? If it's not in it, then we'll add it criticals dot add index. Then initial weight is going to be init weight plus what's our weight? Edges index 2. Right? So these are the ones we have to include. And this is not going to be this. This is going to be my criticals. I mean, it's not really criticals, but these are the edges that has to be there. And this, surprisingly, this has to be an empty set because we don't have anything that we want to exclude. Nobody is excluded, right? So this is going to be collections.empty set. And we say if this, let me make this one smaller. So if this is larger than minimum weight, right? Wait, hold on. So we are adding an edge that's not critical, right? We're adding an edge that's not critical, and we try to find the minimum weight. And if the minimum weight is equal to the minimum weight, then this is a pseudo-critical edge. So I'll add this index, right? If this, well, add. If not, doesn't matter, then I'll remove index. It's like still a little bit backtracking here. We remove, right? Now we go to the next one. Now we go to the next one, the next one, and we go through everybody. So we get this. Now when we return, this is going to be criticals. This is going to be, you know what? Let's make it more explicit. Don't call it criticals. We call it critical set. Okay, critical set. And we'll do critical set, and this one we just need the pseudo criticals. All right, new solution. Dear me. Well, we can try it here. What? What the hell? It looks good. It looks good. But they only have 4 and 5. What in the actual hell? All right. All right, don't worry. Let's put a stop sign here first. All right, let's debug it. It's fine. Okay, doesn't matter. So we're here. Let me just step over and see the mean weight is 7. 1, 2, 4, 7. Correct. Mean weight is 7. That's fine. Okay. Now we need to check, is this one correct? 0, 1, 2, 3, 4, 5, 6. That one is correct. This is correct as well. So we have both correct. Now we are going through them and we're trying to add to the critical thing. So we do this. How do I step out? No, you step out the entire thing. Oh, still not the most. Like, I don't want to go through all the. Oh, I can set another. So I can just resume. Yes, now it gets out. Now we can say the critical. The critical set is empty. The hell? Critical set is empty. That doesn't make any sense, right? That doesn't make any sense. Removed edges. We go through all this. And if it's not in the removed edges, right? If it's not contained, it's this. And I don't have any DSU at the beginning. We need to get inside. We need to get inside to see what happens. So can I redo this? Rerun. Okay. I will do F8. Okay, critical set. Gaga. I will step into this. Okay. Let's see if the n equal to 5 removed edge shall be 0. Yes, 0 is removed. Initial edge is we don't have initial edge. Initial weight, we don't have initial weight. That's good. So we create a DSU. That's good. Edge list shall be 0. This one didn't do. Now we're gonna go through the sorted edges, every one of them, and we'll also stop if the edge list is equal to n-1. Okay, so we get a first one. Index is 0. We shall skip. That's good. Next one, index I is 1. Yeah, index is 1. Then we shall add it. That's this. Okay, so W total weight now is 3. Good. I think that was the this I don't know which one got skipped. Which one got skipped? I do this. 1 2 2 3. 0 3 got skipped? Huh? Hold on. Sorted edges. I equal to 3. Edge list. Edges is 1 2. I is equal to total weight is 3. And I is already equal to 3. 0 1 2 3. No, I is 4. I skipped 1. I skipped 1. Why? Edge width is 2. Why did I skip this? Okay, let's do it one more time. I don't understand. So I need to step into, which one's into? F7. Now we'll do this. Okay. And F8. First, good. Second, good. Okay, so now 0 1 2. Right? Now I equal to 2. Okay, I equal to 2. 2 3. Index 0 1 2. Weight is 2. Okay, now we can say this is true. Right? AB is 2 3. What's in AB is 2 3? So that should be fine because I have 1 2. Right, 1 2 in it. 2 3 shall be able to get it. Let's see. AB index. Remove edges. This is true. Can I step into this? Two, 3. False. Yeah. So that one is true. And can we? Yeah, this one now we enter. Huh, weird. Earlier it didn't enter, right? Edge list. So now edge list 0 or 1 2. Oh, my bad. I think I misread it. 1 2 is 0 1 2. Is this one? Yeah, this one. I equal to 3. 0 3. 0 3. Shall be able to add 0 3. Right? AB is 0 3. Index is 3 is not. 0 3. It's true. Huh? How? I don't understand. Yeah, it says it's the 0. Why did it change to 0? What? The first coming in 1, 2. Right? First comes in 1, 2. Did I do the DSU wrong? And the second comment is 2, 3. So it's 1, 2, 3. And now it's 0, 3. What the hell? Let me redo this. Get into this. Okay. Da 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 da. Get into this. Right, that's good. Okay, so rank parent. Wait a second. Wait a second. X or Y is 0, 1. That's not right. That's not right. 0, 1 not supposed to be in there. Because I removed. Oh, phew. That was the first one? No, it was not the first one. I got into it from here. Right? I redo this. I forgot. Yeah. Right? Hash set. Removed edges. 0 is in it. Which means this index is 0. So the first one shall not do. Index is 0. Remove edges that contains 0. That's true. So this shall be false. Now it's right. What the actual hell? Okay. So we add another one. Now add 3. 0, 1, 2, 3. We shall add this one. It did not add this one. It did not add this one. Let me redo this. First one, skip. Second one, I want to go in. How is this one 0? Oh. Wow. What a bug. What a bug. What a bug. Oh my god. What a bug. Now I wanna see if it's gonna run. Index out of bound. Oh, I have new issues. Where? Array index out of bound. Where? Union find. That is interesting. That is interesting. That is interesting. How is this possible? Unless I add them wrong? No, that should be fine. W is weight, right? AB weight. Parent X. I guess we need to debug again. My goodness. It's alright. Let's just debug again. What the actual hell? Is this one fine? Yeah, this one's fine. AB 0, 1. But DSU shall now go, right? So DSU shall now go. Next one is 1, 2. DSU goes. Next one is 2, 3. DSU goes. Next one is 0, 3. DSU goes. Yes. Next one 0, 4. DSU goes. Huh. And we have added, what did we get out? Edges is length is 4. We add 1, 2, 3. Wait, what do we add? What edges do we add? We added a 0, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Yeah, that's fine. 1, 2, 3, weight is 8. If it's larger than, yes. Now we go to the new one. Then we all get in. Yeah, it's the same thing. Three, 4. Yeah. That's good. Right? Next one. Try it. Didn't do it, right? Critical edge is still size 2. Next one, try it. Index. Index 4. Index 5. Index 6. Okay. So the critical set is correct. Critical set is correct. Okay. This is fine. So we got 2 initial weights. So initial weights is 2. Now again, we do the same thing. If critical contains, next one contains, next one will add this, right? Initial weights added. And then we'll go. Initial weight is 4. Yeah, initial weight is 4. And initial list, edge list dot get. Ah, I see. Yep. I know. Yeah, this is wrong. Edge list dot get I. Oh, this is the edge list. Yeah, I was confused earlier. Okay, so this is gonna be int ei of edge list, right? And then this is not this. Yeah, I was confused earlier. Now I know. Edges, no. Edges, EI. Don't have edges. I need to know the thing. Okay, so edges EI 0, edges EI 1. Now, I don't want to debug. I think this one looks promising. Gosh, hold on. Like for one thing, we don't need this one anymore. We don't need to remove, so we can release this. Okay. What a problem, huh? I think if this one passes, it's well worth the effort. Well worth it. Okay, let's go try. Please pass. It's like 2 hours. Please pass. Please. Oh. What the hell? No critical edge, I say. It's okay. Let's now we're not giving up. We are not giving up. We're very close. We're very close. We can do this. We can do it. We can do it. Just need a little bit. I'll just do this. Right. Just need a little bit. Just need a little bit. Then we're all good. Okay. Run it again. I say no, but 3 is supposed to be a critical edge. I don't know. You wanna run it first? I mean, how am I supposed to know, right? 6. Okay, we have 0, 1, 1, 1, 2, 1, 0, 2, 1, 2, 3, 4, 3, 4, 2, 3, 5, 2, 4, 5, 2. So these are nodes. And the answer is number 3, edge number 3, 0, 2, 1. This is the... That's okay. Let's debug this. Let's get into it. Okay, let's first get into it. Just, we just go, doesn't matter. We just want to go and then see how it looks like. Okay. 5 edges because we're 6. That's good. 0, 1, 4, 5, 3. I don't even know which one is 0. 0, 1, right? 3, 4, 5. 0, 1, 0, 1, 2, 3. Oh yeah, this is the critical one. Oh, I see why. Because this one is gone. Your critical weights. Yeah, when this one is gone, it's not even connected. It's not even connected. So you have to check, right, if it's connected. How do you check if it's connected? You check if it's connected by changing this. Instead of doing rank, we need to do count, right? We need to count. Count what? How many is in how many is in this? Yes. So we need to do a count. So this count is the number of nodes contain the number of connected, right? Connected nodes. Count I is the number of connected nodes with I as their parent. Yeah, this is a trick I learned before. So we're going to do count. That's fine. And if count is larger than count, right? Then we're just going to go there. If count is larger than no, everyone should be 1. This dot count I shall equal to 1. Everyone should be 1. Initialize to 1 because each one count by themselves. So if this is larger or equal to, then I say this, right? And then count px plus equal to count py. So everything from py goes there. Else, if it's smaller, then there'll be the reverse, right? Else, then count py shall plus equal to count px. We always group to the one with bigger. Then I don't need all these. Okay, so now once we're done, right, then we'll say dsu dot find 0, its parent, then dsu dot count this. If it's equal to n, means it's connected, I return this. Otherwise, I return integer dot max value. So we need to check if the graph is, if the MST is connected. Okay, we stop it and let's go to the here, run it. There we go. That's the check. That is the check. Trust me, I am not unhappy about this at all. This is one of the most complex Java stuff I've ever written for a very, very long time. Okay. Pass. What do you think? 2 hours and 11 minutes. It's tough, but the hints are very helpful. I mean, if you see the hints, yeah, you get an idea, but the actual implementation is is definitely not trivial. I mean, if I did in Python, I think things will get a little easier, maybe. I think I might implement this again tomorrow in Python. I have to do Python, otherwise I'll forget. It will get easier, but like this to check if it's still connected. Nah, this is something I didn't realize before. And the general idea is also, my idea is to find everything. Now you cannot find everything. You have to do these 2 steps. Yep. I am pretty sure there is a better way of doing Java. I'll do this tomorrow. Man, what? Is this a nightmare? No, it's not a nightmare, but it's honestly, I mean, it depends. Do you think it's a good interview question? Well, you need to know Kruskal. And then, I mean, this could be a hint, right? If the interviewee, if the candidate knows Kruskal, well, kudos to them. But I will not say a person is like not valid just because they don't know Kruskal. You can give Kruskal. You can even say you can use union find to detect redundant edges. That's all fine. But I think these 2, hint number 3 and hint number 4, should be, one shall be able to come up with this. So I'm pretty disappointed that I didn't come up with these 2. Wow, what a problem. What a problem. But hey, it's I did like debugging for so long, right? This is the first time I debugged for so long, and boy does the debug work, right? I think this which one? This one, right? This bug, this EI bug, this one I would not detect just by myself. What a problem. Love it. Learn a lot. Learn a lot. Kruskal algorithm. I think I have encountered it before, but definitely not at the same level as today. Oh, all the Java shenanigans. I think I spelled it wrong. The good practice of debugger. Yeah, all in all, this is quite a good experience. This was a very good experience. I mean, the hints are very helpful. The hints are very helpful. Basically, we use Kruskal to find the MST weights. Then we remove each edge and recompute Kruskal, recompute MST. If the weight increases, this is actually the definition. This is a definition of critical weights, right? Increases, the edge is critical, right? After that, we pre-include each edge. Actually, I just need to include one edge. I actually don't need to include all the critical edge because we know the critical edge will be included no matter what. Yeah, which means it can be further simplified. Yeah, we just need to include one edge. We pre-include each edge and compute MST, if the resulting weight is equal, right, to the actual mean weight, the edge, putting each edge, not including the critical ones, right? If the weight is equal, then the edge is pseudo critical. I don't even know what's the runtime of this. Each MST, what's MST? Each MST is, you go through all the edges, right? Each MST is O edges, and we have to go through them V times. That sounds reasonable. Ooh, what a problem. All right, brain drained. All right, I will do this one more time tomorrow in Python. All right, that will be it. I will see you guys tomorrow. Adios.